Muito boa noite a todos. É realmente um privilégio contar com a presença dos senhores nessa noite. Eu vejo aqui conectados conosco 105 participantes nesse momento dessa sessão. Essa sessão que tem planejamento para durar 1 hora e tenho certeza que vai ser muito proveitosa do ponto de vista educativo, muito prática a sessão, em que nós vamos discutir um dispositivo relativamente novo da Medtronic, o Telescope, um Guide Extension. E para essa sessão, hoje à noite, eu tenho o privilégio de contar aqui com o meu co-moderador, Dr. Oscar Mendes. Dr. Oscar, todos conhecem, diretor e cardiologista intervencionista do Instituto Favaloro, em Buenos Aires. Também como debatedor, Dr. Luiz Pérez, de Concepción, no Chile. Vamos ter a participação também do Cristopher de Moraes, responsável por Training e Education nessa parte de coronária da Medtronic. Também vai nos falar sobre o dispositivo, as características do dispositivo. E nós teremos também 2 casos, como eu mencionei, uma sessão que tem que ser bastante prática. Estimulo aos senhores participantes a enviarem suas perguntas pelo chat. Nós teremos, então, o Dr. Maurício Cohen, um cardiologista intervencionista muito experiente, todos os senhores conhecem, diretor do Cath Lab da Universidade de Miami, extremamente experiente, que vai nos trazer 2 casos demonstrando a utilidade desse dispositivo. Então, eu, sem mais delongas, passo a palavra ao Cris de Moraes para nos apresentar um pouco do dispositivo. Por favor, Cris.
Muito obrigado. Thank you. Muchas gracias.
No solo somos médicos, somos extensiones de sus vidas. No solo somos profesionales en salud, también lo somos en llegar aún más lejos. No solo estamos en una consulta o en una sala de hemodinamia, estamos tan cerca que conocemos lo mejor para ellos. Telescope no es solo una extensión de catéter guía, es una extensión de todos nosotros, hacia la vida, hacia el bienestar. Y ahora, juntos llegaremos más lejos para estar más cerca de todos. El camino comienza hoy. Bienvenidos.
Good evening, everybody, and welcome to the launch of Telescope, our guide extension catheter. My name is Sinead Darcy. I'm a research and development engineer based in Galway in Ireland, and I worked as part of the design team for Telescope. Sadly, we can't be there to see you in person this evening, but I just wanted to send a quick message to say that we're very excited for you to get the device in your hands. We know you'll do great things with it, and we look forward to hearing your thoughts. Enjoy the launch and very, very best wishes. See you again soon. Bye-bye.
All right, thank you. Boa noite, buenas noches. I'm very honored to be here with you today and talk about our new guide extension catheter, Telescope. My name is Cristopher de Moraes. I'm a global training consultant. I'm based out of Santa Rosa, California, and I'm part of the Medtronic Coronary Artery Division. Next slide, please. So before I talk about Telescope, I wanted to provide an introduction of how we developed this product. So we first started with you. we talked to 700 customers around the world, specifically interventional cardiologists, and asked what was important to you in a guide extension catheter. From that, we tested our product in 30 preclinical models. These include porcine as well as cadavers. And then finally, we looked at a MOD database. This is a database in the United States that anytime a customer, a doctor has issue with a product, it gets recorded. So we looked at issues with the current guide extension catheters on the market and tried to improve on those issues. Next slide, please. Now, the first need that you told us you had was deliverability, especially in challenging lesions. You wanted superior deliverability to be able to get your products to those lesions. On our next slide, you'll see some of the key product features that helped us be able to achieve that. So on the bottom right-hand corner here, you see the push wire. The design of this helped us be able to get the force required to deliver this. The next aspect is around the polymer. So you see here in the middle, the proximal part of the catheter is stiffer, it's more rigid. So this helps to give you the support to be able to push through and transfer force. But as you go distally into the green area, you'll see that it's more flexible. So this helps you to be able to make it the flexibility to get in through certain lesions such as tortuous lesions. And then finally, on the bottom left corner here, you see the TrueFlex tip. So physicians told us they wanted an atraumatic, softer tip, and we designed one specifically for that, which I'll talk more about. And then we talked about the areas of inside and outside of the catheter. We were made very specific. So on the outside, we put a hydrophilic coating to make it more flexible and deliverable. And on the inside, we have a Teflon liner that is very soft and helps transfer and deliver the products. The next slide, please. So all of these product features together, you see in the bench test. The next slide. So here you see the results from our internal bench tests. So this is where we took our product and compared it to other products on the market today, other guide extension catheters. So you see the amount of force required to take this product a certain amount of distance. And you can see clearly here that telescope required less force, hence a better deliverability of the product, especially in challenging lesions. Next slide. So here you see the cross section. This is the push wire that I first talked about. This is one of the key reasons for the deliverability. So if you compare a cross section of telescope versus the other product, you see that the cross section surface area is maximized. And if you can go to the next slide, please. So this maximized surface area helps transfer more force proximally to distally. Next slide. There you go. So you see the force as you push on it, it'll transfer more and help it improve its deliverability. Now on the next slide, you'll see the second key need that we're told by our customers is that you want a soft, flexible tip. So this helps you, especially in difficult anatomies, make it atraumatic. In the next slide, you'll see what this TrueFlex tip is composed of. So a lot of the guide extension catheters that are on the market today, they have just one polymer. So the polymer that is made to create the main body of the catheter continues all the way to the tip, which is typically a more rigid polymer. But here for the telescope catheter, we specifically made a polymer that is softer that we call TrueFlex. And you see here the first 5 millimeters of the tip are made of that polymer. The first 2 millimeters have no coil. And then the 3rd millimeter is made of a marker band that's made of platinum iridium to help make it very radiopaque for you. The next slide, please. And then on these results, you see the force required to bend or make it flexible, the tip. We put this in a crimping machine that then sees, very sensitive, and sees how much force is required to make it flexible or make it bend a certain amount of angle. And so you see here, a lot less force is required for telescope versus some of these other products. So keeping its flexibility. Next slide. And so the final key need that physicians told us around the world is that you want to be able to deliver your products, your stents, balloons, and other devices easily and smoothly without any damage, without it catching anywhere. And so that's where we developed the smooth path technology that I'll show you on the next slide, please. So the smooth path technology is made of 3 different parts. So you see here the push wire, the distal last 10 centimeters of it are tapered, and I'll talk more about that, including show a video. And then you have the second part, which is the polymer on-ramp that helps get the device ready to go into the third part, which is the entry port. If you can go to the next slide, please. So here you see the slow tapering of the last 10 centimeters. So you see it slowly gets, so this device is guided through, it makes it easier and easier to go into the on-ramp. The next slide. So this is an actual wire that you'll see how it slowly gets tapered until it gets into the on-ramp. One more time. And if you can go to the next slide, please. And here are the 3 main parts of the on-ramp. So you have the proximal, that's the start of the ramp. Then you have the longitudinal segment. And then this all guides it, it scoops it into the entry port. And as I mentioned before, this is made of a special polymer that is softer, and it helps capture the devices and move it into the entry port and along each section. And the next slide. Another key aspect of ours is if you come into curvatures, such as you see in the picture here, the marker, there's a spade-shaped marker on it that helps you see where it should be positioned so that the device can go easiest into there. So as you see this in the imaging, it'll be very clear. And for whatever reason, if it's not properly oriented, this product is made in such a way that it will almost self-twist, self-orient itself so that the marker is on the outside, making it easier for the device to be transferred into the entry port on the inside part of it. And then to the next and last slide. So as a summary, we've created this product based on what you, our customers, have told us from around the world. And we focused it on 3 main needs you've told us. One is the superior deliverability. And a strong component of this is the push wire. Second was the tip. We made a specific tip called TrueFlex to help make it very soft, very flexible, and atraumatic. And finally, the smooth pass technology that I just discussed about to help you transfer your devices into the entry port and take it to the lesion. And that is all. Thank you very much for the opportunity to talk about this.